Welcome everybody. Let's wait a few minutes. We have a Jarosław with me. Jarek.
Hello guys.
Let's wait, and we need to switch the camera first. Let's test. Camera for Jarek, yes.
Hi guys.
Jarek is with me in the same room, so no worries, but we have a social distance here. Actually 2 meters, so everything is fine. Welcome on the first webinar, Open Virtualization Pro this year, 2021. We will talk about the OpenShift Virtualization.
Exactly.
In the next 30, maximum 40 minutes. So we don't want to, take you more. Let's go with the slide. And here we go. This is what I said, Jarek. OpenShift Virtualization is still a new subject, actually. We'll talk about what we have in the latest release, how it actually works, what is the design behind how it's worked behind the scenes.
Exactly.
But the most important part is the key is when we should use this actually technology. If it's for the newcomers, which thinking about the OpenShift, or maybe this is the solution, for the people who is actually using some different kind of the virtualization. We'll see, of course.
Yeah. So I will try to answer those questions during my presentation. So bear with me.
Let's go.
Okay, so let me quickly introduce myself. So my name is Jarosław. I work as a solution architect at Red Hat. I'm focusing mostly on the application and developer-oriented technologies like JBoss middleware and OpenShift container platform. I'm kind of focused recently mostly on the cloud solutions that are that we provide as a Red Hat.
And myself, my name is Paweł Mączka. I'm one of the founders on a Storware company. Our goal is to provide data protection for the modern workloads, such as containers and the other virtualization engines. Today, I will be the host, of course. You are the special guest, so all of the slides on your side, Jarek. So let's go.
Exactly.
Let's move on.
Yes. So let's get started. So the idea of running containers and virtual machines as a containers in a containerization platform might sound kind of strange and complex to implement, but if you really start looking in more details on both technologies, you might see some similarities between them. So as we know, what containers are really doing, they encapsulate some processes, and if you know how KVM works, so the virtualization layer that is built in Linux kernel, it also runs virtual machines as a operating system processes. So they are quite similar, and also both containers and then virtual machine, then they consume pretty much the same resources. So they need some compute power, they need some networking, they need some storage. So they are quite similar, and really the key component here is the KVM. So with Red Hat OpenShift Virtualization, we didn't try to reinvent the wheel, but we really wanted to reuse existing experience and virtualization technology that we already have and we use for over 10 years as part of our virtualization platforms like Red Hat Virtualization or the OpenStack platform. So in a nutshell, how the virtualization KVM works and how it is built. So there is a KVM Linux kernel module, which provides the access to the hardware resources, and on top of it, there are two other components. So QEMU, which is kind of low level of virtualization, the emulator, basically the emulator of different hardware resources. And then there is a libvirt, which is a daemon and a library that allows you to run and execute the virtual machines on the Linux host using the QEMU.
So Jarek, what I'm guessing is that we're using the same KVM technology that
Exactly.
and libvirt that we used to use in KVM legacy platforms, or the OVIRT itself, for example, or the Red Hat virtualization.
Exactly, yes.
So it's the same technology stack.
Yes. So
okay.
It's exactly the same KVM, and actually, of course, there are some differences here. So actually, there are two major differences. The first one is that, as you can see on the picture here, we create a container which contains a libvirt and QEMU inside, and those components, they are communicating with the kernel to run and execute the virtual machine. So so there is the same technology stack, but we packaged the in OpenShift Virtualization. We put the KVM into the container, and you will see later that there is always, when you start a VM, there will be a virt launcher container or pod started, Kubernetes pod, where those KVM layer is running. And of course, we also changed the management layer. So in Red Hat virtualization or in OpenStack, you have some hypervisor and some management layer that manages your virtualization cluster. Here, the management is done using the Kubernetes, so the kubelet and other Kubernetes components. So moving forward, how can we run those virtual machines in Kubernetes? So first of all, we created an operator, the Kubernetes operator, which allows you to enable this virtualization capability in OpenShift. So using the operator, you will install the OpenShift virtualization functionality into your OpenShift or Kubernetes cluster. And then using set of CRD files, configuration files, you might configure the operator to create, run your virtual machines. Of course, as I mentioned in the beginning, virtual machines needs storage, so because we need to store the drives, the disks of our VM. We also need some networking to allow some services that run in the VM to communicate with the external world. Mm-hmm. And here we also leverage the built-in Kubernetes capabilities. So we have the native integration with the SDN layer, so with the container networking interface implementation that we have in OpenShift. And also we integrated the OpenShift virtualization with the Multus, which again is a component of OpenShift that allows you to communicate, to integrate the networking layer directly with the host networking. So you can bypass the Kubernetes SDN, you can plug using the Multus directly to the host networking interfaces or to some network devices like SRIOV, for example.
Yeah, just a question, because I think many your customers or the partners asking, okay, is it the right time to put or do it in an opposite way? Because most of the market right now is putting the containerization workloads on the virtualization layer. Yeah, in most cases VMware does it this way. Yes, the Red Hat's saying that you can do it in opposite. So put a VM into the container. As you said, in operator, we'll see on a live demo. What's the advantages in this strategy?
Yeah, so basically the idea is to let you have single management layer for both containers and virtual machines, and we know from our experience that you never will migrate all your applications into the containers. So for those workloads that you cannot, for any reason, or you don't want to migrate to containers, we offer the possibility to keep them as they are now in most cases as a virtual machines and run them in the OpenShift and benefit from all the from all the value that Kubernetes and OpenShift gives you.
Okay, fair enough. Let's move on.
Also the storage. So the last part here. So we use, of course, the Kubernetes storage abstraction layer. So whenever we always need some disks to run our VM. So those disks will be stored in persistent volumes, which are native storage components of Kubernetes. So moving forward, also we have integrated the virtual machine management layer with OpenShift. So if I hope you know a little bit OpenShift, so you can manage OpenShift two ways. So there is a web console and there is a command line interface. So with OpenShift Virtualization, you can leverage both of those options. So the virtual, the web console, OpenShift web console allows you to manage the whole life cycle of your virtual machine. So you can import the disks of your VM if they already exist somewhere. Then you might stop your VMs. There is also an integration of the monitoring stack with the OpenShift monitoring, which is based on the Prometheus. So all the metrics, all the resource consumption metrics are stored in Prometheus, and they are available for you to analyze them. Also, they are visualized in the OpenShift web console. Also, what is kind of interesting feature is that we support live migrations. Yes, so it is possible, for example, in case you need to stop a node where your VM is running, to execute the live migration of your VM to other node in your cluster. This is implemented again using the KVM built-in functionality. So we didn't reinvent the wheel here. We just leveraged the existing capabilities that are part of the KVM for many years. The only requirement here is that you need to use the shared storage. So the storage that provides you read-write many Kubernetes capability. And the other interesting capabilities we have also implemented is the possibility to import virtual machine disks directly from your existing virtualization platform, where we support both the Red Hat virtualization as well as the VMware. So we have a built-in tools to import the VM images. You can also clone your VM disks easily in the platform, and you can also create a snapshots for the offline machines, so the virtual machines that are powered off. And moving forward, as we already spoke about it a little bit, really the main use case for OpenShift virtualizations is to let you run easily and seamlessly both the virtual machines and the container spots within a single platform. So we don't really, at least at the moment, we don't position this solution, this component, as a replacement of existing virtualization platforms.
This is what I wanted to ask. Are you going and saying, okay, let's get rid of all of your virtualization stack and go in with the OpenShift virtualization? So you say no, it's a great enhancement and the option for the new projects, I guess. Yes, because where the containerization is taken in the first place, this is a great add-on that some of the workloads that are natively could use in the OpenShift environments, like application part, etc., could be or could be even migrated into this technology.
Exactly. Yeah. So I think now the main use case here is really to in case you migrate your applications to containers, you might find some components of your application difficult for any reason or impossible to containerize. but you might already run them as a VMs, or you might find it quite easy to do it. And this might be a solution for you to be able to run both VMs and containers, the one application within single OpenShift or Kubernetes platform.
Yeah, the single pane of glass, the one management is, I think it's crucial, because right now, we are dispersed into the different technologies, different UIs. So if we can put it into one, it can be a great benefit.
Yeah. So now I think it's a good time to go ahead and start the demo. So this time.
I spoke with Jarek before and said 10 slides, not more. I don't want to boring all of the audience. So let's go. We're now move on into the live demo, and we'll start from the scratch, showing how to add a virtualization actually operator, and see how we can manage the virtualization machines and the application inside.
So I have recorded this demo in advance, because virtual machines will never be as fast as containers. So
that was a good one.
Yeah. So anyway, having in mind the time limits we have here, I recorded to speed up some.
So you're quite sure that this on display everything will works properly, because it's already recorded.
Yeah. So this is the side effect, that you can be sure that everything will work here. Okay. So what we have here, we have a OpenShift cluster, OpenShift 4. Cluster, and the first step is to install the OpenShift virtualization operator. So from the operator hub, just like you would install any other operators, it's very basic operation. After the operator is installed, you need to create the instance of the OpenShift virtualization in your cluster. So again, there is nothing here that you need to fill in any data. You just click next, and it will quickly provision virtualization. Let's say it will enable virtualization capability. So you can see here a lot of pods created, which are enabling all the functionalities that are needed by the virtualization. And with that, we can move forward to create our first VM. And actually, this time I will first create a VM template, so that we can reuse the template to quickly create multiple VMs. So here, what we need to provide, a location of a disk that will be booted, used to boot our VM. And in this example, as you can see, I'm using the Fedora disk that is available under some URL.
And you choose the flavor, so the size and the number of the CPUs and the RAM.
Of course, you can also define some flavors in advance, so that you can have a kind of dictionary of T-shirt sizes that you want to choose. Next step is to set up a networking. Here, as you can see, by default, the VM will be integrated or will be connected to the pod network. So this is the SDN, the network that is created to connect all the pods, all the containers running in the cluster. So we don't use here anything else. The storage here. So I provided the URL of the disk of the Fedora, in this example disk. So there is nothing here to add. I'm just showing here you that this disk will be stored in the PV, Kubernetes PV. So I'm creating here the cloud init script to be able to authenticate. You can also attach CD-ROM, for example, if you want to have a template. If you want to have for example, ISO with the packages that are available in the distribution. And this concludes the creation of VM template. So having the template, we can quickly create a VM. So again, you can see there is a wizard here. When we provide a name, we select a template, and then the form is filled in, so no need to change anything unless we want to somehow customize the VM. And we are done. You have option to immediately start the VM or not. I didn't select the box, so now I'm starting the VM from the UI.
The question is because right now you did manually create the machine. What about if you would like to fully automate it, like with using Ansible, or what will be the goal to automate it?
Not Ansible, not necessarily Ansible. I mean, all those configurations they are created using some YAML based configuration files.
Okay, so it's YAML based configuration.
Yeah, so you might instead of using the wizard, you might create a YAML CRD file that defines your VM, and you might install it in your cluster just like you would install any other YAML based.
Okay, because I'm thinking about the scenario when somebody, the administrator, needs to do it. I don't want to do it every time manually, so there is a procedure that you just give me a flavor, and I will. So what I need to do is I can have a set of different YAML configuration files, and I can use one by one. Yes.
Exactly. Yes.
Okay.
Yes. That's how you can automate the process, and of course the YAML creation and generation and installation process in Kubernetes might be automated using any tools you like. Okay, so the VM has started, so we can have a look on the console here, the VM console. We have, as you can see, the VNC console. Also, there is a serial console here available out of the box for Linux. VMs, so just quick.
What about the Windows? Of course, it's supported. Yes,
for Windows, yeah. Actually, you will see later on the Windows VM. So I just added it recently. So what I'm going to do now, of course, I will log into the VM, which has already started, and I want to show you here how you can expose a network via network some service that is running inside the VM. So I will install here the Apache server, which will be exposed on the port 8080, and then I will show you how to create a Kubernetes service so that this HTTPD server, and of course the application that runs inside this HTTP server, can be exposed to other pods that are running in your Kubernetes network. And then now also I will create later the root, OpenShift root, so the ingress, so that I will also expose this Kubernetes service to the public network outside of the Kubernetes SDN.
So the Apache on this VM will be treated as a application inside the container, so that it will be quite similar way.
Yeah, from point of view of the of the other application, this will be just any service that could run in the container. Right. So here I have installed the Apache server, and you can see here that for every virtual machine that is running in the OpenShift, there is always a Virt launcher pod started. That is kind of entry point to access the VM from outside, so from the cluster or from the outside. So what I need to do now, I need to create a service that is pointing to this Virt launcher VM. So I'm creating here the standard Kubernetes service. The only modification here is I need to create a label where I'm specifying exactly which virtual machine for which virtual machine the service is created. Because by default it might send a request to any VM. Okay, so I need to finish the creation of the service. Here I need to modify the name of the namespace, and then we have the service. And now I will expose the service as an OpenShift root, so that you can access the service from the outside of the Kubernetes network. So I'm using here some default configurations and just need to choose the service, the port 8080, so the same like I have in the VM. And now you can see that when I click on the service, it gives me the access to the service. Okay, so
I can imagine if we have more services on the specific VMs, we need to do the same path. Yes,
so exactly, yeah. So if you might, for each VM, you might create separate service that exposes multiple ports. It's quite flexible. But really the point here is that, you create a Kubernetes service, Kubernetes ingress. So it's all the same way as you would run your application in the container. Okay, so now I think the next thing here is I want to show here is the live migration. So first I will show you what will happen if you will, why it is important and required to use the RWX, so the shared storage. So in this VM is using RWO, so the not the shared storage, and you can see here the message that because because I don't use the shared storage, I cannot run the live migration here. So to fix that, I need to create a new VM based on the same disk, but where I will use the RWX storage. So here I will show you quickly how it is done, and basically here is the moment where I need to make sure that I'm using the RWX storage. So I need to.
So by default, you have RWO always.
Well, it depends on how you set up your cluster, because you specify the default storage class in your cluster. So if it would be RWX, it would work by default, but you need to really make sure here that you are creating a disk using the storage class which supports the RWX access mode. So in this example, I'm using, you might notice, the OpenShift container storage, so the Ceph-based storage, which provides the RWX support using the Ceph-FS. And here I need to specify that I want this disk to be RWX. And the rest remains the same. So I'm creating, booting the VM. Of course, this will happen faster than before. I speed it up a little bit. And here, what I wanted to show you is that the live migration process is pretty fast. So to prove it, I just run some. I call the Apache server that I have installed before every second. So you can see that the response 200 means that the response was received correctly from the HTTP server, and this will run during the live migration. So here you can see the IP address of the node where the VM is running, and now I'm executing then the migration. And you only click the button, and the rest is happening automatically. So it is especially very useful when you will have some maintenance or some upgrades which will require restarting the nodes, cluster nodes, and this might also require to restart to migrate the VM. So you can see here the IP address has changed, and then I hope you have noticed it was pretty fast, but in this example, there was no interruption of the service. Of course, it is not guaranteed because it really depends on what is the networking you are using. So this
on my side, it works.
Well, this SDN is pretty fast. So the change of the network interface was less than a second, which is nothing special here if you take into account that this is the Open vSwitch based software defined networking. But of course, if you would use some host network, which some maybe SRIOV device or something like that, of course there might be some interruption of your service. Right, so the next thing I want to show you here is the command line interface. So we have seen so far the web console, but pretty much all those capabilities, the same functionalities are available using the command line interface. So the first thing I'm doing here, I'm connecting using the virtctl to the VM console, which I can also easily access from my command line interface. Of course, first I need to log in using the OC login to the project where the VM is running, and the rest is done using the virtctl command. So you can see here that I'm inside the VM. You can see here the HTTPD processes are running, and I'm logging out from here. And we move forward to the next demo, which is the demo of the VM importing. So here you can see we support both the VMware and Red Hat virtualization. So in this example, I will show you how.
This is this V2V migration tool that is already used in RHV?
Yes, exactly, it's the same.
Okay, nice one. I didn't know that there's a possibility to do it.
Yeah, so, but here I'm showing you how you can migrate the VM from Red Hat virtualization. So first you need to connect to your Red Hat virtualization API server. After you will authenticate successfully, you will be able in a second to choose a cluster and a VM in the cluster. So these are the this is the Red Hat virtualization configuration basically. Okay, so now I have authenticated. I can select the cluster and I can select the VM. And once I choose a VM,
what is this long list?
This is a list of VMs that
so that we have on your RHV
in my Red Hat virtualization cluster. Yeah, so you have access to all of them.
And we have all of your names.
Well, actually, yeah, it was really not mine.
But I stole it.
And yeah, and we click import, and that's it. So this will start the import process. So the import process is also implementing using the container. So there will be a pod running that that will execute the import. So here you can see we see in the virtualization view that the import is executed. We can see the progress, and in a second we will see that there is a pod, importer pod, that is executed, and is and basically this pod is executing the import from the ref server. And the last demo here, I wanted to show you how you can import and run the Windows, Microsoft Windows VM, because it's kind of fun to see the Windows screen inside the OpenShift. So this time I'm using the virtctl image upload command. With this command will basically import the Windows disk from my local hard drive to the cluster. So again, it is done using the on the OpenShift side. There will be a persistent volume claim, as you can see, and there will be a pod that executes this import. So here we can see that it has finished, and now I'm creating a new VM. So pretty the same wizard, just different parameters here. So
we have two questions, but I don't want to skip them. I know it's not yet the QA, but it's I think time when you create in the machine, it will works fine. First thing, how many it's quite difficult. I don't know if we have an answer. How many snapshots we can store, or if we have a snapshot capability on the specific VM in OpenShift virtualization, actually.
Yeah, so we have a snapshot capability, but only for offline VMs, so the VMs that are powered off.
Okay, so it's not yet available. I know that there's a dedicated API for the backup and recovery vendors, so for sure this capability will be available soon in the most vendors that it will be applied to the OpenShift and OpenShift virtualization with the OADP API that is already, working in a new backup and recovery vendors ecosystem. Well, Storware is one of them, but I shouldn't mean about the Storware. I don't know from where I know the Storware team. The next question was, does it support about the flavors? Because we show that there is not the flavors, but also the supported systems like Windows, CentOS, Linux machines. What about the macOS? Is it possible to run the macOS machines here?
Well, if you have only QCO to image, then it is, yes.
Okay, so if you already done it, so it should work without any problems.
Yeah, so let me quickly finish maybe the demo. Because
sorry if I apologize.
Yeah, because it's like maybe 1-2 minutes more here. So I used exactly the same wizard. What will be different here? I will just specify the disk that I have imported before. So instead of the URL of the image that I was specifying earlier, here I will choose the existing PVC. I think what also I have to do here manually is I need to define a disk definition with the bootable disk definition. So this is what I'm doing here now. So I need to specify the disk I have imported and choose it as a bootable, and then we can go and yeah, again, I didn't start the machine from the wizard, but here I have a easy way to do it now, and we should see in a minute the console with starting Windows and
yay, Windows 10.
So you can see the holy grail of
of the Bill is running
of the IT industry. So running Windows.
The unicorn of the desktop machines.
So now you can recognize a screen from the Windows.
I didn't recognize the place.
I can recognize the image, not the place, from other Windows machine. And here you can see I can log in from this.
I thought it will be blue screen here, but
no.
It's either this is a blue screen, but with the information about this machine.
Yeah, so this concludes the demo itself. I have the environment running also. So maybe just quickly one more thing to show you. So this Virt launcher pod. So when as I mentioned, when we start a VM, there will be always a Virt launcher pod started. And here what I wanted to show you is that what it has inside it basically runs the QEMU KVM process. So this is a process that starts the VM. So you can see here that this VM consumes as many resources as the VM itself needs to run. So based on the flavor configuration you will specify, it will consume that many resources. So for example, you can also apply here Kubernetes quotas and limits of the resources that are available for the pods. So pretty cool technology. All right, so this I think this concludes the demo itself. And any more questions?
Yeah, so this is a great time for you to ask the questions. So feel free to go on a chat and ask. Also, Leszek, I see showed where is the YouTube channel. So please subscribe on the channels if you would like to see the past webinars or see what we'll do in 2021. Definitely will be more subjects that will go and deep dive. What I want to say is, when I first time saw the OpenShift virtualization, I said, okay, the idea is good, but I was a little bit worried how fast this integration will go. Lately, you showed me that you worked on a demo, and it just looks really, really promising. And I was quite surprised. And after our session, I go to my team and said, "Hey, it's going for real. this virtualization inside the container. So it's not only the slides, but Red Hat is really doing lots of effort to make it happen. and I'm really curious about the future, because like I said, there are two different, I don't want to say vendors, but two different approaches. The containers on a VM, or the VM on a container. And because the containers are really rule the world these days, this approach can really applied, and can be quite a significant switch in the future in the IT industry. So definitely, worth demo, worth to watch the presentation. Thank you for it. Let us know on the chat how did you like this approach.
Maybe one more remark which I didn't mention. So the OpenShift virtualization is fully supported in OpenShift 4, starting from I think 4.5 version, if I remember correctly. But it is only supported on the bare metal clusters. So we don't support the nested virtualization when you run your OpenShift cluster in VMs, and then you start nested VMs inside the cluster. So it's bare metal only, and in the near future it will be bare metal only. Of course, this might also include a bare metal services in public clouds, but not the nested virtualization.
Rob is asking, Paweł Mączka, could you show us how to get backup and restore by OCP virtualization? Yeah, this is a good.
This might be a good topic.
It's quite a good topic, but we decided that we'll not mention the backup and recover. This is actually one of the topics that we would like to do in one of the next webinars. So stay in touch, Rob. You will see. Like I said, there is a totally new API that the OpenShift team provide for the vendors like a Storware to work with it. So please be patient. One of the next webinars will be applied. I don't want to right now, kill the stage here. The major topic was go through the major features here. But yes, it's possible. We're working on it at this point. How about important functions on OpenShift, such as self-healing, horizontal scaling? How can work with the virtual machines?
So self-healing definitely works with virtual machines. So if your VM will go down for any reason, it will be automatically restarted. For automated scaling, I'm not sure. I would need to check it. So maybe we keep it offline. My good feeling is that it is not supported with the virtualization. But yeah, I would need to check to confirm if there is any way to use the auto scaling capabilities of Kubernetes and OpenShift.
Next question: does NS6T supports OpenShift virtualization? This is a quite I don't know. What about?
Well, I'm not sure, because I'm not sure if you can use NS6T on the bare metal. I think it requires the VMware virtualization.
I think it should.
And this would lead you to the nested virtualization, which is not supported.
So the more secure answer is no today. But we'll double check. Yes, check it. Yeah. A VMware NS6. Yeah. Rob, got it. We don't think so, because it requires bare metal, yes. and it's yeah. So
OpenShift virtualization requires OpenShift cluster running on bare metal, so I think it will not play well with NS6T.
Okay, so I think we're done exactly to 46 minutes, 45 when we started. This is how we plan it. Really good topic. Looking forward for the next session, because I don't think that we did everything. There will be the next releases this year, so definitely we will come back with this topic. But remember, Jarek is our master of the OpenShift subject, so definitely we will find more. Yeah, you do our best, and it goes well. So we'll giving us any feedback, what topics you would like to see maybe in a future webinars regarding the OpenShift virtualization. I know that the backup and recovery is one of the subjects, so I will do my best to prepare the next session based on it. But if you've been if we didn't have enough time to touch such a subject that you would like to apply, just giving us a sign. Go on the Open Virtualization Pro, or find us on the Facebook, YouTube, on the other social media platforms, and do not hesitate to contact us directly here. Jarek, really, like always, that was a pleasure and fun to spend the time with you. Even if we started with quite a cold scenario because it's the winter, but this is the first hour meeting in 2021.
Exactly,
So looking forward to have you more frequently here in these crazy times, that we still live in.
Yeah, sure.
So thank you, everybody. Have a great day. Thank you for your support. We had all the time quite a significant amount of people. Have a great day. Stay in touch. There's one last question. Nilesh says, please cover. Okay, novel network OES provisioning followed by backups is coming period. So our question is about the novel OES.
Novel OES.
I will take this question, Nilesh, and I will let you know because it's quite tough one. So we'll grab it and also see what the Rob is asking. So I will just do the screen. We're running out of time, so I will do my best to come back to you with the bunch of the questions that you put it here. No worries. We are here for you. So we got your email, so we'll contact you directly with this question. Again, thank you. Have a great day. Stay in touch, stay safe, and see you on one of the next Open Virtualization Pro webinar with our experts.
Thanks, guys. Bye.
Cheers.